Now, joining us for a discussion on innovative sourcing for defense critical elements, please welcome Global Head of Sourcing at Oerlikon Surface Solutions, Manoj Kamatkar, President of e-Vac Magnetics, Samuel Trinch, and Critical Materials Engineer at Lockheed Martin, Samuel Stein. Moderated by Senior Government Specialist at Project Blue, Jen Snyder.
Hello, everyone. I would first like to thank SAFE for inviting me to moderate this panel today and putting together a wonderful panel, and I think we're going to have a great discussion today. Our panel brings together 3 different companies that are currently actively rebuilding the U.S. industrial base, both for commercial purposes and defense purposes. Our conversation will examine how far the U.S. has come so far, our remaining gaps, requirements for scaling up domestic production, and requirements for qualifying for defense production. We'll also talk about how the Department of War needs to evolve its acquisition and investment approach to sustain this progress. I would like to open up with a question to all the panelists. The U.S. industrial base needs a wide variety of critical minerals to produce defense applications. As we've already heard on many of these panels at the summit today, China dominates the mining, extraction, and processing for many of these critical minerals. So my question to you is, how far has the U.S. come in rebuilding domestic and allied supply chains for these particular minerals, and how much further does it have to go? Sam, would you like to kick it off?
Sure. Thank you. I'd also like to just express our appreciation for this event, because it's really happening at a critical time in our country, which everybody knows. We've heard a lot about what's happening in China and the control that they have, but thus far the US government has really taken an all-in approach, which is really critical to address this problem. Some of the early investments in the upstream is needed to ensure that we have access to these materials domestically, with either from the United States or from our allied partners, setting up those relationships, and then continuing to invest in the midstream and downstream, because that's really a big challenge. So we've done a great job in the upstream, and we've begun to outline various, like XM, the vault, of course, potential other options, but a lot more to do. The momentum is amazing, and the administration has done a great job setting us up right now to really put the country in the position to be successful for the next 250 years.
Yeah, I think, Sam's, we got to keep going. Lockheed, is in discussions with his partners that the U.S. has invested in already. I think the one good thing, a lot of the hard work was done within Lockheed being a big OEM, is this caused Lockheed to go into their supply chain 7 tiers deep and kind of assess, where there's gaps that need to be filled and where these investments could fill those gaps. I just joined Lockheed in December, and I wasn't, there's 4 major business areas. So aeronautics, you think of the F-35, space, everyone watched Artemis 2 capsule or Orion capsule. MFC, missile fire control, so PAC-3 and THAAD just got, Lockheed committed to accelerate production of those. And rotary mission systems, RMS, where the Sikorsky line sits. So historically, I think a lot of those business areas were very programmatic. RMS solving a tungsten issue or a rare earth issue is not really going to communicate to MFC, but all that has changed. So now, with these investments coming online and Lockheed's business areas looking at those to fill their gaps, they're all talking now. And they're all talking through our corporate critical material management team, which is great, and great to see, and just keep going, because I think there's a lot of good investments, and Lockheed is really committed to leveraging those.
Thanks, Jen, and thanks, Saif. Glad to be here. So from Oerlikon's perspective, I would like to break it up in different stages where we are. So technology was never a problem, because this was moved in late 60s from US or Western countries to China. On engineering side, we have seen very interesting samples from our partners, and we are also doing our internal testing here. In terms of ramp up, actually where we have seen, so from our need, I still see we are at least 12 months to 18 months away from where our actual needs are. Okay, and qualification, actually, this is interesting part. This used to be the most difficult part for us, especially coming into aerospace. But now we have seen some flexibility from our customers. So we have seen commitment of from 2 years to almost less than a year for qualification. So that's a very good thing. The last challenging part is like commercial sustainability. Okay, that's a key point. But I would say it may sound counterintuitive, but thanks to this export controls or whatever we have seen in last 20 years, because everybody is flexible. So the base is going to increase. At the same time, our partners, the US manufacturer, will also improve in next 12 to 18 months. That's what I see.
Excellent. Thank you for your comments. Now I kind of want to delve into each of your companies a little bit more here. Sam, e-Vac Magnetics has achieved some major results in the last year, so it would be great if you could talk about that. And also what you see as the most critical gaps that are left between where we are today and a truly resilient and secure mine-to-magnet supply chain here in the US.
Great question. I'm going to start with giving a little history of e-Vac, as you mentioned. So we're a proud part of this effort, and we've been supporting the administration's mine-to-magnet initiative for the last more than 2 years. And so we're part of the VAC group, which is actually a 103-year-old entity, but we're wholly owned by Aura Partners, which is a private equity firm based out of Houston, Texas. So if you were here yesterday, you heard one of the managing partners, Charles, talk about Aura and how they approach their portfolio companies. So they really look to scale. So in the last 10 years, they've deployed 40 capital projects. And of course, e-Vac is one of those projects, potentially one of the larger projects. So in December of 2023, we took a soybean field in Sumter, South Carolina. And with the administration support, with the support of the state of South Carolina, the governor, with the county, Sumter, the city, we were able to employ a lot of the items that have been done at the federal government, so permitting expedition. So we knew all along up front exactly what was required for each step of our permitting process. So we had that information available. And instead of waiting for a long period to review it, the commitment was to review it initially, tell us where we needed to change it, but if we provided everything, to pass it and move it through. So we were able to not let permitting be an issue whatsoever. In parallel, the administration provided 2 presidential declarations, basically to help us accelerate long lead equipment purchases. And this is really critical. So we were able to do that with the administration's support. And then with that 100-year heritage that VAC brings to the party, frankly, we have facilities today in allied nations, roughly 3,500 employees based around the world, R&D center in Germany, so Hanau, Germany. Actually, it's a spinoff of 100 years ago from a precious metals company, which is right next door. Part of that spinoff was the founding of the vacuum oven, so melting metal in an oxygen-free environment 100 years ago. Still today, we're making some of those metals for the commercial market. So over that period, we have roughly 425 patents, but frankly, a collection of trade secrets that you just can't get from school or learning. You have to get that from actually deploying technology, scaling, and supporting customers. So we've been a key supplier for the defense industrial base for over a decade from these allied countries, and we're bringing that to the United States with the administration support and with Aura support. So that has been an amazing process. So we took that soybean field from December of 2023, and in November of 2025, Secretary Bessent toured the facility. And he was able to, during that visit, return to Washington with magnets off of that line for the president. So the first magnets produced at scale. But over the next month, the team continued to work very aggressively. And in December of 2025, e-Vac out of Sumter, South Carolina, delivered the first neodymium iron boron sintered magnet produced at commercial scale in the United States this century. And so we were very proud of that. Clearly, we're still expanding. Right now, we have roughly 150 full-time employees at e-Vac, During the construction phase, we were employing over 900 people. So we were literally working at wartime speed with our construction partners, again, with the administration and with the city and the county to deliver that in 24 months. And we have further plans to expand, which I'll talk about more. So the administration has done a great job putting our plant to build permanent magnets in the ground and under operation. However, we have to further integrate on site so that way we can eliminate these points of failure that occur. As Sam mentioned, he has to go 9 deep in his supply chain. So the mine to magnet supply chain is very cumbersome. It starts with getting it out of the ground. You have to take that material and get it to roughly 90% of rare earth content. And that's done near the mine and location. But then to get to separation to 99+% rare earth materials. That's where China essentially has a choke point on the entire supply chain. Almost everything goes to China for separation, metallization, strip casting. So what we will do on site as a next step is bring the metallization on site. So we can bring in oxides from the United States, allied nations, and then we can turn those oxides into metals on site and then produce our magnets very efficiently, control our supply chain more effectively, and deliver a cost-effective product, which is really also what's needed.
A quick follow-up question for you. I know as we've talked, you're largely focused on the commercial sector, but you also have a secondary focus on obviously helping the defense sector as well. So how do you handle this need for scaling up commercial production to reduce your costs and really be an economically viable company here in the US with qualifying your products for the defense sector use?
Yeah, we were very fortunate, frankly, when we launched this project that we had a commercial partner, which is critical to deploy the level of scale that we've deployed. It was over a $500 million investment that we made in those 2 years to build a roughly 500,000 square foot facility that's fully capitalized to build these products. And so in doing that, we, again, worked with the Department of War, and we have various lines set up so that way we can run 100% Department of War demand without any issue. And if they're in a surge time, we have the ability to flex up that capacity by using the other equipment that we have. And being in business for 100 years, and frankly, 50 of those years, we've been making soft and hard magnetic materials. So we've been delivering this product for 50 years, or versions of this product. So we're essentially experts on managing our inventory for our customers. About 25% of our business today is for automotive. A large portion for aerospace, the industrial market, the consumer market. So we've had to deal with all different type of consumers and customers. And with that, we have the ability to flex and manage our inventory. And fortunately, we have facilities, not just in Sumter, as I mentioned, in allied nations. I've spent a lot of my career developing critical components for really critical applications, semiconductors and lithium-ion batteries. 20 years ago, we had factories that were taken out by tsunamis or fires, and they were the single source for major automotive manufacturers. So we learned early on you need multiple sources, even inside of the same company at different locations. So we have that ability to support our commercial customers, all of the defense industrial base, both in Sumter and in our allied countries.
Great, thank you so much. Now, Manoj, I kind of want to turn to you and talk about your company a little bit more. You produce thermal sprays that are needed for our jet engines, our turbine blades. Your company also produces tungsten carbide and many, many other products. What are your critical mineral supply chain concerns, and what steps is your company taking to address these concerns?
Thank you. So all these are very critical for our end product, but at the same time, I will not put all them in one basket. For example, the carbides. We had some exposure for China. Okay, but right now, the good thing is for aero carbides, we have domestic suppliers. That's a good thing. Second, we also have recycling stream, where we are actually doing some drill bits and then getting it done in the finished products. At the same time, the challenge is it's not enough. It's not enough because the thing is happening, the customers are asking more and more. So we don't know exactly whether it is a real demand or everybody is in panic. So we need more. That's a very key thing. And we are actually helping the US suppliers what they want from us. So we are helping them on the upstream process as well, if they need some carbide particles as well. So that I will say tungsten carbide. Coming back to chrome carbide, okay, it's not today's problem, but it can be tomorrow. So here also we have domestic US suppliers, US, Canada. Fortunately, this is not export control to the extent like the other rare earth, but it may happen anytime. So chrome carbide also, we are in comparatively good shape. Now coming back to the most challenging option. The most challenging option is rare earth, which I will bucket like yttrium, yttrium metal, yttrium oxide, gadolinium, but mostly yttrium. So here we are really doing something. To the title of this topic is creative things. So we are working with the US suppliers right from day one. It's not like that we are just after them to give us capacity. We are helping them on capacity. We are helping them on upstream also, where we can get you yttrium oxide for yttrium metal. So in some cases, I must say that here still we are far away, like 12 to 18 months on the upstream, because the friendly countries where we have this yttrium oxide particles will still ramp up in next 12 to 18 months. But now, fortunately, we have some creative options where our suppliers have 4 to 5 years worth of stockpile, which they can recycle very interestingly, and we can get our yttrium oxide. So that's where we are.
Thank you so much. Sam, let's talk Lockheed Martin here. You guys are interesting and a little bit different, given the wide range of critical minerals and components that your company needs to source. How are you dealing with that, number one? What is your supply chain concerns, your top priority supply chain concerns, and how are you looking to kind of balance that need to keep your costs down, at the same time, develop a resilient supply chain?
Yeah, good question. So Lockheed is unique in that, we're not buying raw materials. We're buying components, subcomponents that are getting incorporated into our systems that have these raw materials in them. So the first part was mapping that out, where our requirements are. We did that. To mitigate that, we have to get creative. When a rare earth comes out of the ground, it doesn't get on to an F-35 for 2 to 3 years. So it is trying to, with these new investments coming online, trying to align when our sub-tier suppliers are going to need these materials, when Lockheed's going to need the component to get on the F-35 to make its delivery schedule. That mapping with our sub-tier partners is taking place and is necessary. The other part that I would add to that question is that Lockheed, they have a wide variety of materials that they care about. And so it's not just rare earths, but it's composites, chemicals, metallics, you name it, that are incorporated into the systems. And different materials have different properties. So one way we're looking at it is, like, can we design out some of these materials that we really don't need? Do we need a certain grade of a rare earth permanent magnet that has dysprosium and terbium, or can we get by with a magnet, a lesser grade magnet? So that's one thing we're looking at. The other thing we're looking at, the margins at the midstream processing step are razor thin. When you get up further downstream, Lockheed doesn't want to not be able to deliver an F-35 because they can't get a tungsten metal or germanium. So where can they assist with their sub-tier in the mid-tier processing step to allow them to process what they need to give to Lockheed? So if there's an investment within expanding capacity, Lockheed purchasing, buffer material to support them, we're committed to support our sub-tier suppliers and to ensure that Lockheed can get that final component. So that's one thing that I think, we're kind of forward-leaning on, that we want to have. We're not trying to pick champions, but when people are coming online and meet that, delivery schedule and can meet the quantities we need, that's who the programs want to go work with. The other creative, I think, step that we're working on is long-term agreements. So I know we'll talk about Vault and the National Defense Stockpile a little bit later, but can Lockheed enter into some of these long-term agreements to support our sub-tier suppliers is something that we're considering. Has our executive leadership backing on that? Because they don't want, it goes back to, how much raw critical materials make up an F-35. It's very small. And they don't want to have that be the limiting factor of why we can't keep delivery schedule. The other thing that we'll add is that we're looking, I mentioned designing differently, but we're also looking at, if a program is looking at some of these new sources coming online, is data sharing. So there's a big hurdle to qualify in defense. So just say a magnet was qualified on a PAC-3 munition doesn't mean it's qualified on an F-35. It still has to go through a rigorous qualification period. But there could be data shared across all these programs that, hey, we looked at an e-Vac magnet, this is how it performed PAC-3, here's the data associated with that. And that really helps, as these programs are navigating, I won't go into a whole DFARS lecture here, but, navigating the DFARS is something that they're not, historically at the raw material level accustomed to doing. So data sharing across Lockheed is very imperative to meet the DFAR requirements.
Okay, I am going to take advantage of you today and the fact that you recently came from the US government and worked at the National Defense Stockpile to ask you some questions from the government standpoint here. So how does folks at the Defense Logistics Agency and the National Defense Stockpile determine criticality for the defense sector?
Yeah, so it's a good question. I think a lot of people get confused about the different lists that the government has. So, the three lists I can think of is the USGS critical minerals list. I mean, they're mandated to identify materials that are essential to the U.S. economy, national security, and are susceptible to or vulnerable to supply disruptions. So it's very broad. You look at things like contribution to GDP, concentration of supply, vulnerability to or susceptibility to geopolitical disruption, and they have that list. DOE's list is very, energy transition focused and technology focused, and then DLA's, while they don't publish their lists, they have a congressional mandate to look at a very specific lens of a national emergency, a conflict, and what it takes a 3-year rebuilding period after that, and when the materials need to rebuild, what's lost during that conflict. So that they look at very unique defense items. So further up or further downstream, typically that USGS and DOE might not look at. But there are, when there's a material on all three lists, obviously red flags are raised, but doesn't mean that something's not critical if it's not on one list. I can give a good example. I think grain-oriented electrical steel, which is used in transformers, was on DLA's list, it's on DOE's list, it's on the USGS list. Does that not make it essential or critical? And then another one, I think silver isn't on any of the lists, if I recall, but if you talk to someone at Lockheed who is buying silver at its all-time high price in January, they're gonna say that's an issue for them. So the overlapping, it really can give you a good idea of where priorities should be, but that shouldn't be the list shouldn't say what's critical or not. It's gonna be different for every company.
So you have an advantage here where you've looked at this topic and the supply chain concern issue from the government perspective, as well as now you're working for a defense contractor and you're looking at it from their perspective. So what do you wish the government took into consideration today that they're not already thinking about? Whether it's something related to stockpiling, investing, the financing side, loans, what is it on your mind that you wish they were doing more of or taking into consideration?
I think so. There's two things I can think of. The first one is, I think, data sharing. So DLA and the Department of War, they spent 2 years to develop a requirements report that gets sent to Congress that outlines a lot of these industrial-based issues at the raw material level and how it affects DOW systems. It's great data. It's not proprietary, company proprietary. That could help someone like Lockheed, what materials should we be caring about at a high level. So data sharing, I think, is a great way to facilitate conversation of what should be priorities. The other one is the big, I would say, the bottleneck. Everyone says mid-tier processing, midstream processing. I think it's qualification. There's these huge qualification timelines. people don't have the capital to invest in that, I will pick on DLA again. They have a great qualification. Well, I wouldn't say great, but it is something that allows companies that know they can be qualified in some of these systems to have the government pay for those costs. More programs like that, expanding that program, or additional programs that can allow companies show that they can have a drop-in replacement for something that is currently sourced from China or one of the covered nations, and get money to do that and prove it. I think that would be a great program to get some more of these investments streamlined into the defense industrial base.
And I know we have a panel later today where they're going to talk about Project Vault a little bit more, but I'm going to put you on the spot since I have you on the stage and get your thoughts on what you think about it from the Lockheed perspective.
Yeah, I think it's a great concept, and I know Lockheed is in discussions with the folks on how it could best fit for everybody. I think it's just a better mechanism than what currently the National Defense Stockpile serves as. They're congressionally mandated that they can't release it. You know, the Honorable Duffy was here yesterday. He's actually the stockpile manager. There needs to be a whole line of a process to initiate a release. It's not very straightforward, and there's a lot of red tape. So, you know, if the stockpile is buying material, one, that's in short supply right now, not good. It's taken away from someone that really needs it. And two, even if you got it in the stockpile, it's really hard to get out. So Project Vault would allow companies to access material. How that mechanism works is still, I think, being hashed out. I think the announcement's actually tonight is when they officially launch. But I think with all the red tape associated with the NDS, you know, Project Vault will serve a purpose to allow some of these commodities that people are coming online and want to contribute can help Lockheed by supplying to the vault. So,
perfect. So, I kind of want to go back and get all of your perspectives on this next question in terms of what you think is most needed to accelerate the defense industrial base access to critical minerals over the next 3 to 5 years. And you guys have been pretty quick in answering my questions, so I'm not going to confine you to just one thing. You can talk about multiple policy actions or things you want to see from, you know, the private sector as well, whether it be on financing from private equity firms or something else. I will open it up. And if you want to kick it off, and we'll give this guy a break for a few minutes.
Go with the other Sam?
Yeah, go with the other Sam.
Well, clearly I would love a guaranteed offtake, okay? That's what every manufacturer would love, but we realize that's not always the case. But there are those policy items that will help manufacturers in the midstream and downstream. As Sam mentioned, the margins tend to be leaner in those stages. You know, to take oxide and turn it into a metal, essentially that's a cost, and we just need that as part of our process. But controlling that is really critical. And so if we implement that step in North America and hire North American workers and use materials to feed that process that are predominantly from the USA or allied nations to then make a permanent magnet to deliver to critical applications, it would be very beneficial to have a production tax credit. So the use of taxpayer dollars to bring jobs, very good careers actually, back to North America to support this really critical supply chain that we need to continue to build out. So, I mean, there are a lot of things that I would like to see. That's one in the short term, that there is a lot of momentum and support, which again has been part of the administration's success, is getting this momentum and driving a cohesive strategy amongst Washington, which hasn't necessarily been the case. And so if that continues to get momentum and can pass, it will offer a credit for a scaling amount. So if you make a lower end high performing magnet and you use predominantly most of your materials from non-foreign entities of concern, you can get a $20 tax credit per kilogram of magnetic block manufactured in North America. That's the proposal. all the way to if you produce a higher performing magnet that goes in some of these critical systems, the last thing you would want is your munition to get 90% of the way to its target, right? So these magnets are ultimately critical, but they're not a massive amount of them, frankly, needed for that application. Interestingly enough, it's very hard to support all of those, the supply chain, but the total volume for that defense industrial base compared to a normal medium-sized commercial program is smaller, okay? And so that's why we need those commercial programs to support and offset the smaller volumes from the defense industrial base. But with the tax credits that scale across the various technologies, it lets us take advantage of all the costs that we're putting in to deliver these products. So that's really important to a midstream and downstream manufacturer.
Manoj?
So, yeah, I would say whatever you mentioned, Jen, a combination of all will be really helpful. And then, no offense, but in government policies and support, everything is actually addressed to magnets too much. So I was actually complaining in our meetings, hey, come to rare earths. So some of that aspect, balancing of those, support, probably the help on rebating is also helping the investment. That's great. At the same time, from Oerlikon perspective, the alternate or substitute thing, let me tell you, Scoperta is a very, very innovative solution which Oerlikon has. Okay, and many of our customers are coming back. We are still not there, like alternate to any of rare earth, but we are working on some substitution to yttrium, definitely. And those are still in the test phase, not for a full solution, but for a partial solution. The other case we have done creatively that, if the usage in the overall coating is, say, 1, then how we can do on the lower side of the specification and then still meet the ultimate application, correct? That's what we are thinking. So how smartly we can use the available stockpile till we, in next 12 months, ramp up. So that's our goal.
And then Sam, your thoughts?
Yeah, I think so one thing from, I guess, industry that really helps Lockheed is just, clear timelines. Like when we reach out, we're trying to map when our programs are going to need and when you will have the volumes and the capability. So just clear timelines is something that I think is really beneficial for a major OEM like Lockheed. The other thing, I guess I'll give an example, is one thing that worked really well with the material was scandium. So scandium, we kind of have been working to develop that supply chain before it's widely adopted, getting it in place, essentially. So from the mine to the end user, who is Lockheed, so the mine, the separator, the alloyer, the additive manufacturer, powder maker, the part maker, to Lockheed. Once Lockheed and the other users start heavily using that material, the costs go down at those levels. So that structure is being set up for scandium and scandium aluminum alloy that I think is a really good poster child of how you can develop these supply chains smartly and not have the issue of a bad actor like a China dominating that market. The other thing that I already mentioned is the qualification piece. More programs, whether government or some type of consortium that can really help get these capable suppliers over the hurdle of defense qualification, which can be time-consuming and costly.
One, I've had private discussions with all of you. So one thing I'll throw out for whoever wants to answer, kind of taking a step back again from your specific companies and looking at the problem that the US has in securing its supply chain across these wide range of critical minerals, is the multiple stages of the supply chain that need to be solved. Is there anything that you guys, you kind of come from different parts of the supply chain and you kind of have slightly different concerns. So is there anything that you would want to highlight about what the government needs to be thinking of as they look to solve a problem in a more holistic way across these stages, or what you think they need to be thinking about to make sure that we establish long-term, economically sustainable supply chain in the United States. You want to take a shot?
I'll
Okay.
take a shot first, because I wanted to play on some of the things Sam mentioned about qualification, because it directly aligns to how to be sustainable for the long term. Because sustainability is not just green and clean, it's cost competitive, right? That's a really important element of sustainability. And you know, the qualification process, not just for the government, but for a lot of the critical applications, automotive OEMs or aerospace OEMs, it's very long. And today, if you look at the number of magnets that is used by the defense industrial base, the various specifications, right? I think there's 35 or 40 different versions. And so e-Vac and VAC has been working with Lockheed and the other primes to call that down to, let's say, under 10. And so that, you know, the magnet manufacturers, we can focus our rare earth production on only a specific number, a much more manageable number that can then be qualified and either put into the stockpile or put directly into the supply chain to meet those requirements on time. So the other thing, hitting timelines, that's a really critical element. And you know, one of the things to make that happen in any industry is cooperation, right? And that's one of the things that the administration has really continued to drive, is cooperation across the supply chain, from the mine to the end user. And we got to continue to do that and share information. And sometimes we don't like to share a lot of information because it's very critical. These, you know, these products are very hard to make, and frankly, timelines are hard to hit. And that's a differentiator for e-Vac, because for VAC, when we say we're going to hit something, we do everything in our power to execute. And it's with that 50 years of history making these products that let us do that. But we still need to cooperate. We still need to help the ecosystem. And together in 5 and 10 years, you know, we will have a demand in North America when we bring in the end products that will use the magnets, whether or not it's a humanoid or military or EVs, HEVs, wind turbine, you know, all those applications that you've heard about. You know, we want to make those in North America, of course. And you know, the demand can be about 50,000 tons a year in 5 to 10 years, in 10 years. And so we're going to need multiple good suppliers across the entire ecosystem to really be successful for the next 250 years. And to me, it's about cooperation and sharing information.
Yeah, I would say, sorry.
No, go ahead, Manish.
I would say data-oriented approach will be more helpful, not only for the materials which are today's problem, but also the future problems. Okay, right now, there is support, there is a momentum, but there is underneath, there are some hidden problems. So data-oriented approach will be very useful in my view. Okay.
I have one other question for you, Manish, on this front. You mentioned right now trying to understand the demand, especially with what you're looking at. We've seen the roller coaster ride, shall we say, in the yttrium prices. And I know you're highly focused on that right now at your company. Are there any concerns for you in trying to figure out how you plan ahead for the demand side, right, in terms of what your customers are needing? Is there anything that you would like to see or need help on to get a better handle on that, or what is your company's strategy?
Yeah, definitely. I will put it in 2 stages. One, where actually companies like Oerlikon, not only Oerlikon, where we are supporting the mid-industry. For the midstream, okay, we are spending considerable money. So that is actually not coming on the forefront. So there we definitely would like some help. That's one thing. Second, on the long-term sustainability of these prices, because again, we are not going to compare with the subsidized pricing. So there has to be some balance. Okay, so that's where to have a long-term competitiveness, probably that's where we can expect some help, definitely.
Okay, Sam, is there anything you want to add on those topics, or you feel like you've covered it?
I'll just add a few things. So I think transparency. So obviously our engineers and designers are still designing things with these materials in them because maybe they don't know. So giving them at least the information, hey, if you're what you're designing here is going to have a rare earth magnet, it's going to have tungsten, it's going to have yttrium, it's going to have skin. Give them that information, I think is important. And the other thing I will add is, yeah, the materials today might not meet the requirements for or might not be able to meet future requirements. So really understanding where the gaps are currently and keeping the future in mind, not just trying to firefight right now is an important piece, and Lockheed's just trying to do both, firefight, but also get up these long-term strategies in place.
Okay, now I'm gonna open it up. If there's like a key message that you want this audience to walk away hearing from this panel, what would it be? And you'll have to give them a moment. I didn't prep them for this. Whoever wants to tackle it first,
I'll take it first. I think so. I mentioned this before. Lockheed is, I think, willing to sign these letters of support, make these long-term agreements, just not with we can't do it with everybody. Our requirements are not large enough to do that. We are, I think, willing to do that. It's just how the timelines and project schedules align is how we're looking at it. So I think that's really important, as there's a lot of up-and-coming suppliers that I think are great. It's just where it aligns within Lockheed's timelines is where they're going to make their investments and agreements.
You want to go?
It's a catch-20 situation, correct? Every time when this situation comes, suppliers, they ramp up, but the companies are not ready for like 3 to 5 years of contract, because everybody is thinking tomorrow China will open up and all those things. So one key message, which actually we are experiencing, we are signing like long-term contracts, no matter what. Means we know that not you are locking the price, but you have some collaborations. Okay, next 2 years, this much. Then we will work together the next 1 year. That will be the tear-down approach. So, and at the same time, we are working with our customers. So that long-term commitment is very important for this sustainable approach.
Great answer. Just to close, from my perspective, I mentioned the tax credit for manufacturing in North America, which is really critical. I think that it's not needed forever, but to get this industry through the next, let's say, 5 to 10 years is really important, somewhere in that period. And then just continued access to low-cost capital to continue to expand, because we aren't done. The whole industry is going to take a lot more expansion. We need more capital. It needs to be accessible faster and at low cost, which is really important, to let us bring in private capital to augment that, and then ultimately to bring in more customers. And so that whole mix together is what I think we need for the long run.
Okay, well, that concludes our panel today. I hope you join me in thanking a wonderful group of panelists to talk about this issue.
Thank you.